The universe is constantly expanding. You've heard that phrase plenty of times, yet have you ever really wrapped your brain around it? If the Earth is a planet in the solar system, which is only a part of the Milky Way galaxy, which is one of countless others in an infinite universe, and the whole thing just keeps growing, what is that? Okay, breathe, and let's take this one step at a time. So, it turns out, there's a lot of space out in space. You don't say! No, seriously, think about it. Imagine if your house, rather than being located on a quaint little street with neighbors, squirrels, and ice cream trucks, was just sitting in the middle of nowhere. I'm not talking about nowhere as in Glasgow, Montana, not to offend you guys in Glasgow, by the way. I mean nowhere. Just a whole lot of uninhabitable space farther than you could walk, drive, or see. That house is our galaxy, floating around on a giant sea of nada. And that nada is only getting bigger as the universe expands exponentially. It all started with the Big Bang, not the TV show. Surely you've heard of this cosmic beginning of all beginnings that took place around 14 billion years ago. Within an itsy-bitsy fraction of a second, as in a decimal followed by 31 zeros, the universe was born. And this baby had quite a growth spurt. It'd be like something smaller than a strand of DNA, blowing up to tens of trillions of miles long. That's also a bunch of zeros, and a long short story. It's ginormous and only getting bigger. And as it gets bigger, it grows faster. That means the further you are away from, say, the Earth, the faster you move away from it. Ow! Space-time makes my brain hurt. So let's scale things back and home in on our little neck of the woods in this ever-expanding universe. The Milky Way is part of a group of galaxies known as the Local Group, our sort of cosmic neighborhood. The Local Group contains tons of dwarf galaxies that are riding on the coattails of the two big kids on the block, our own Milky Way and its even bigger sibling, the Andromeda Galaxy. If you're wondering, a dwarf galaxy is a small galaxy that only contains a few billion stars. Oh, only a few billion. Hey, compare that to our own grand spiral galaxy, which has something like 200 to 400 billion stars. The Local Group is itself just a tiny piece of an even larger group of galaxies called the Laniakea Supercluster. It has over 100,000 galaxies, ours being just one of them. Feeling small yet? Wait, it gets better. That sounds like a busy enough neighborhood to me, but remember that quote of the year, there's a lot of space in space. So these objects are millions of light-years away from each other. Still, it's not like all these galaxies are spread evenly throughout the universe like a well-planned suburban neighborhood. Next to us is a distinct and vast area of nothingness that astronomers aptly refer to as the local void. Sounds kinda scary. And perhaps it is, since our Milky Way is moving away from this thing at 160 miles per second. Oh yeah, and that mysterious void is getting bigger too. How do we know that? Well, by measuring it, of course. Gravity makes galaxies move closer to each other, so these voids expand as objects move away from them. The reason the local void is so interesting to scientists is that the matter that composes the Milky Way and everything else in the local group likely came from the void itself. Astrophysicists hope that these space voids can tell us something more about dark energy, but I'll get into that a bit later. Unfortunately, despite this mysterious empty house sitting right next to ours, it's been difficult to study because we can't get a good view. It's located behind the central mass of our galaxy, and it's not like we can stand on our tippy toes to try and get a peek of the thing. But scientists didn't give up so easily. Think of it like having crummy seats to a championship soccer game. The only tickets you could afford were the ones that had that obstructed view box checked off on the website. You figured it wouldn't be that bad, but when you got there, sure enough, not only are you in the last row of the highest section of the stadium, but there's also a big steel beam right in front of you. Ugh. Even though you can't see when your team scores a goal, you can see them running down the field. Based on the reaction of the players and the crowd that can see what's happening, you can figure out when they do score. Sure, it's not as cool as witnessing it for yourself, but it's better than nothing. That's a more exciting and way less complicated analogy of how astrophysicists were able to measure this void in our backyard. The study's lead author, R. Brent Tully, was also the head of the team that first discovered the local void back in 1987. They managed to get around the obstructed view by looking at the motions of other neighboring galaxies. Using the information they gathered by observing and measuring what they could see and what they had to infer, they were able to build 3D maps of our corner of the universe. This cosmographic map highlights the boundary between the collection of matter, which as I mentioned earlier happens because of gravity, and the total absence of matter that makes up the edge of the local void. After constructing this 3D map, what did we find out? Well, for starters, it shows that just as the universe is expanding, so is the void. Based on the presence of a dwarf galaxy inside the emptiness that's doing its best to escape at a speed of 217 miles per second, it's been estimated that the local void is at least 150 million light-years across. Scientists can tell this because the faster the dwarf galaxy is moving, the weaker the void's gravity is, which means it must be larger. Over the last 30 years, astronomers have been working hard to understand the movement of the Milky Way, Andromeda, and dwarf neighbors. They all appear to be different from the overall understood expansion of the universe by over 372 miles per second. This new study shows us that nearly half of this motion is being generated locally by two things: the pull of a nearby cluster of galaxies known as the Virgo cluster, and the expansion of the local void as it becomes more and more empty. So is this void next to us actually just 150 million light-years of nothing? Yeah, pretty much. There are still some of these dwarf galaxies floating around, like the one they used to measure the void. There's also some dark matter and hydrogen clinging around near those. But other than that, it's a whole lot of nothing. That's why it's called a void, I guess. Ironically, because of all the nothingness there is inside of space voids like our own, these things still find themselves filled up with something. And that is what is known as dark energy. Sounds like something Darth Vader would know about, right? Believe it or not, most of the universe, 68% to be exact, is composed of this stuff. So, what is it? Dark energy is basically the name given to the accelerated expansion of the universe, along with whatever it is that may be causing it. Got that? Well, me neither. And scientists aren't sure what it is, but the best guess is that it has something to do with the vacuum of space-time. And where these vacuums are, there's this stuff called dark energy. Despite the tough-sounding name, dark energy is not very strong at all. As a result, it's easily hidden by the presence of anything at all. Radiation, matter, the gym shorts you absent-mindedly tossed toward the hamper but landed on the floor next to it instead? Hey! Okay, maybe not that last one. We don't get to experience dark energy or matter because our environment is chock full of normal matter, like all the stuff that makes up you, me, and everything around us. But when it comes to voids, like the one next door to our galaxy, they are truly empty to the point where nothing can compete with dark energy. That's why dark energy is free to do its thing and expand and expand and expand some more. The expansion of the universe happens mostly within these voids, and as they push out on their surroundings, they drive more galaxies apart. I guess if we want to visit our neighbor Andromeda to return the lawnmower we borrowed, we may want to leave soon. Otherwise, it could take another billion more years to get there. So, what about you? What do you think about when you look up at the stars at night? Let me know down in the comments. If you learned something new today, then give this video a like and share it with a friend. But hey, don't disappear into a void just yet. We have over 2,000 cool videos for you to check out right here. Just click on this left or right video and enjoy. Stay on the bright side of life.